How's it going?
Going all right.
I've had Christian working on redesigning the device detection and broadcasting and all of that behavior.
Yep.
We have a bug in that essentially broadcasts every second forever.
Oh yeah, that's why I have it turned off.
Broadcast, like it's destroying the network.
Oh yeah, yeah. I purposely have mine turned off, and I literally just click the spinner or refresh whenever I need it.
Yeah.
Yeah.
That's great. So we've got it designed pretty cool now.
Oh yeah.
Like you should be able to turn it back on.
Sweet.
And never care.
Like already in production or soon?
No, it's almost done. We had like a 3-hour design meeting yesterday just to like work out a whole bunch of like internal flows. I've been fighting really hard with the device scanning feature to try to only ever do it
once
when you actually need it.
Yeah.
So we have some behaviors like we're not going to do it on startup, obviously, because every time you reload VS Code, it's going to be like, and we don't want to do that.
Mm-hmm. Yep.
But we're doing all sorts of interesting things like remembering the devices that were on your network last time, so we can just do device infos on them. So we will do that. Like we'll do some device info checks, which should all come back. Like if I have 100 devices on my network and I do device infos, they should all still resolve within like a second if I run them all at the same time.
Yep.
So essentially, most of the time you're not going to need it. It's pretty cool. Anyway, I want to do a deep dive about it later, but we're going from 1 a second to like hopefully 1 every time you sideload at the worst case.
Yeah. Sweet.
Hey, everyone. So today we're going to talk about unions versus intersections, right?
Is George here?
George is probably not. I think he usually has like worship team practice at this time over in the UK.
The joke was because we were talking on Slack about unions and intersections of types, right?
Yeah.
And he said he commented that he doesn't think about it, doesn't want to think about it, right?
Well, no, I think what he was saying is I no longer do thinking. I think he was kind of making a comment like I just let AI do literally everything and I don't care anymore.
Hey,
the way I
see it. my iPods are not working. My
we're good.
Let me see if it will.
Outsource the thinking, and maybe Marcelo will. Hi, Marcelo.
Hello.
Will join in and tell us that he doesn't do coding anymore. He just do presentations, and AI does the thinking.
Oh no. Can you guys hear me?
Yep.
Yes. Hear you. Can you hear me?
So I will take this off. This is not working. I don't know where the keys are. Okay. I will stick with the. Can't hear you. So try this one.
Hello. Can you hear us?
There. It's on the speakers. That's it. Okay. Let's go. I don't want to lose a lot of people's time. I did prepare 3 images I want to show. No PowerPoint and nothing. I will just really demonstrate the current state of the simulator.
I'm going to give like a quick overview of what it is as well.
Yeah. I have 4 of these. There are the things that I want to share with you. So, okay, where Brave Tab. I want to share the entire screen, also share system audio, but I don't know why. Okay, and then share, allow. Okay, I hope you guys are seeing my screen.
Yes.
Okay, let me see here.
And then I think you should probably hide the preview down there. I guess it'll get covered up, but it's like mirroring our video as well. You might just be able to click the X because it's a pop-up, I think.
Yeah, I hope so. Yes. Okay. Can you guys see?
Yes.
This? Cool. Yeah. Gemini and Nano Banana helped me to make it beautiful, right? I made sketches. Actually, this one I didn't do anything. I just wrote down what I wanted, and it did exactly what I wanted. Even adding this fancy text here that I never told him to say to add, but he added that. So, okay. So I would like to talk a little bit about how the simulation project started. So back in 2017, December actually, and almost beginning of 2018, the Hulu team was writing some unit testing, and then they realized that it would be great to have local unit testing. And so Sean, which was one of the team members of the Hulu Roku team, he put together a project called BRS in his GitHub that started as an interpreter in Node.js for BrightScript. Basically, it's a CLI and a REPL that can be called and executed and everything, and run some BrightScript code. It was early at that time. I had no idea this was happening, and I learned about the project in 2019 when I was thinking about how can I make my friends in Brazil to run my Prince of Persia game port for Roku without having a Roku, because they did have there was no Roku in Brazil back in the day. And I said it would be great if I could write something that could run that in a browser or in a computer. So I started actually thinking about doing a C# project. So I was looking for some basic interpreter and in C# that was I was working at the time. And then I ended up founding BRS, and this is TypeScript. I could learn TypeScript, and I could at the same time help the project. So I started actually helping Sean and his team on that. So you're gonna see a lot of collaborations from me. But in the parallel, I forked the project, and I started like adding the Draw2D components, so I could start doing a POC of drawing on canvas, and then in a browser, because his code was all Node.js, no browser stuff. So I started like exercising on the browser and everything. So that's how it came to be. Like the BRS engine originally was called Emulator. It was BRS Emu, but for several reasons, I renamed it to Simulation Engine. So it's now a simulator. But so it was in 2019, and around 2023, actually during the pandemic, the Hulu team was changed. Sean left Hulu, and he kind of stopped developing, and then the project was abandoned around September 2021. And in 2023, we decided that we would adopt that project in our Roku community. And I started like maintaining it. Like basically what I did was I started merging back lots of improvements I did over this time, and then making so BRS in the Roku community is way ahead of what it was, but not as good as what I have in my project. So basically, last year I kind of stopped updating here because it makes no sense. If you want a BRS, CLI and REPL, I already developed the same thing here. So I'm gonna demonstrate how can you use the BrightScript simulation engine the same way CLI and REPL was before. Okay, so yeah, that's where we are. So this is the history, the timeline. Let me now show you a little bit of the project in terms of the repository. So it's just another simple diagram. Basically, the repository currently, it has the core folder in the source. There you're gonna see is where the interpreter is. I'm gonna break down a little bit this in the next image, but basically the core is the interpreter, and Then we have two different consumers of the core, I would say. One is the API, which is the browser. It's for the browser, an API for the browser. And another one is CLI that runs, as the name says, a CLI that runs the Node.js version of core. So core actually is built in two libraries, one for the browser and one for the Node.js. So that's what we see here. So core becomes BRS engine and also becomes BRS Node. And then with BRS engine, in addition, you have the API. So it's another library. And for the BRS Node, you have the CLI. So basically, API comes to here and the CLI comes to here. And core is the same code. That's why I wanted a monorepo, because I didn't want to have different branches for different flavors. It's the same code that runs for both browser and Node.js contexts. And more recently, with the help of the AI gods, I could refactor my code, because I have been developing the SceneGraph thing since last year, but it was deeply ingrained in core. And so it was forcing BRS engine and BRS Node to bring SceneGraph necessarily. And then I didn't want that, because one of the aims of this project is to allow like my games or anybody's games that doesn't need SceneGraph to run in an independent application without the overhead of SceneGraph, because SceneGraph is a beast and it keeps growing, right? So then I decoupled it in an extension. So now we have in the core, we have an extension model that we can extend it for other things. So now it's SceneGraph, but I'm planning to do a SDK1, which is like, so we could run legacy Roku apps with those old screens. And also maybe potentially, if someone volunteer, I know the guys from BrightSign already are asking for the simulation to support BrightSign flavor of BrightScript. So the BrightSign extension could exist in the future. Okay, so now on top of those NPM packages, we have currently 3 projects. 2 that you know of, you have access to the code. BRS Desktop is the Electron app, is the actual BrightScript simulator that I'm going to show a little bit. And there's BRS Fiddle, which is our code sandbox that is created for the community and ended up also opening the code. And there is a BRS website, which is my demo website that has the BrightScript TV. That's private because there is stuff there that I don't want to share at this point. But it's actually very similar to the example I included in the monorepo. If you go to the monorepo in the package for BRS engine, there's a web example there that you can just run. Okay, I will show a little bit later. So that's the overview of how the monorepo is and what it generates, right? So it generates 3 packages, independent packages, and then we have applications consuming and using those packages. So now let's go to the architecture a little bit. So for the architecture, I'm gonna use this. I think I already shared this in the community a couple of times, but this is the Electron app architecture. It's good because I can talk a little bit and quickly about everything that involves an application that uses the interpreter, right? The engine. So basically, here we have the focus on from the right to the left. So the right side, we have the interpreter. This is the core, right? That I mentioned. The core is here. So the core gets an input, which is basically the code and assets and all the references for the shared arrays. I will talk about the shared arrays later. But basically, it will receive the code, like it is a zip file, just like an application. It could be also a BrightScript file, like a text file, any blob. It will identify if it's a zip. It will unpack the zip and create everything. So it will run through the lexer, then the parser, and then it starts interpreting the code. And for that, I have a memory file system that also came through this process, this payload that we receive here. So you can have you have the package zip file, which is a file system, a volume in the file system, a temporary cache FS, and now actually we support extension like this. Like if you have a Roku with a USB support, you can put a USB. That's a ext1 that's also supported now. It had the interpreter, of course, access the internet, and the way we control or we send and receive data to the interpreter is a little bit tricky, because the interpreter is synchronous, and that was deliberate from the original developers, and I kept it because of performance. I made a POC using asynchronous code in the interpreter, but it affects heavily the performance. So for now, it's still synchronous, and so the only way we can send data to a synchronous process in JavaScript is through shared memory. So that's why we use heavily shared array buffers. And you're going to see when I'm talking about Rendezvous how I'm using that. But basically, to get data, I need shared array buffers. To send data outside for the render thread, I can use post message. I just send, because it's a worker thread, like a regular worker thread in a browser or in Node.js. But when I send post message, the render thread will get the data, right? So to get data, I get from shared buffers. To send data back, I send with post message. Then we have, this is the API layer. Of course, in the CLI, this will be the CLI layer, but here is a web application, so it's the API layer. So the API is not only it's a library that has several components that handle multiple things, because as you can imagine, the interpreter, all it does is to read the code, create variables and objects and everything, but what it does spit back to the API. It spit back screen frames, basically, of course. So every number of frames per second that you define, it will send the screen frames to be shown. It also sends print messages, because if you print something in your code, it should print in the console. So it will send print messages. And other commands, like for the video display and everything. There's some controls for the video, for the audio and sound and display. So these components in the API is a separate library, a small library that basically handles like input to read the zip file and create the blob to send to the interpreter, and also to communicate to whatever application is using the simulator. So the simulator boundary is these two layers here, right? So these are the simulator boundary, the core and the API, right? And this the core running on the thread have no interaction with the browser. Only the render thread has interaction to keyboard, gamepad API, video, canvas, and everything. And the console, it could be accessed by the API, but also could be accessed. The API could send the console data, the logging data, and the application will be responsible. So in the case of the desktop application, which is this design, the console is handled by the application, not by the API. So basically, then in the desktop application, it will handle the UI, the test, the status bar. There's another thing here that in this design that was not there yet, which is the editor, like the BRS Fiddle. Now the desktop app has an editor. So there is another component here that is not represented here. And this is the rendered thread for the Electron app. So the Electron app, if everybody have a developed one, has two threads. One is not called actually threads, but it's two layers. One is the render layer, which is actually the browser layer, which is shared between the API and it. And there is the main thread, which is the main layer in the Electron app, which is Node.js. It's Electron, but it uses the same Node.js APIs. So basically, in the main thread, that's where I simulate a Roku device, because here is basically simulating BrightScript. But here I simulate a Roku device because I implemented all the services like the web installer to install apps or to get screenshots. I will demonstrate all that. ECP and Telnet, so you can connect the Visual Studio Code to the simulator, right? And even I reverse engineered ECP2, which is not documented by Roku, but I reverse engineered, and then the Roku app, the mobile app, it uses ECP2, not ECP. It's WebSockets, but our application is recognized by the Roku app, and you can launch applications and control as remote control the application, right? So this is an overview of how the simulator works, right? So, but I want to go one more slide only, which is the one that I just finished this morning, which is the threading model. That made me, like, by yesterday night, I finally finished the Rendezvous implementation of SceneGraph extension. Oh, what's happening? Show my screen. Oh, I think it's because of the loop. Okay, sorry. The loop. Anyway, sorry. Here it is. You guys still see my screen? Hello?
Yep. Good. So version 2.1 was released yesterday with the Rendezvous implemented for SceneGraph. The implementation of SceneGraph presented a few challenges, but the most complicated one is Rendezvous. And Rendezvous is a problem for us as Roku developers, but it was a bigger problem for me as trying to reproduce this behavior in JavaScript, right, in a browser. So the way I fixed that or I managed that was the same way I managed the remote control problem with the core, which is using shared array buffer. Is the best invention of JavaScript ever. Shared array buffer is basically an array that is shared among threads. So you can pass a reference for it to the worker thread, and whatever you update in one thread, it's visible as shared memory in the other one. So I used multiple different ways in different ways, and this model shows quickly how it works. So what I call here the render thread and the main thread is different from what Roku calls it. This is important thing. So Roku main thread is where the main the BrightScript starts, and where the source and main function starts, right? And then when you start SceneGraph, you start the render thread. It's not in the simulator case, it's not that. Main thread for me is main, and the Roku render thread is the thread where the scene executes. So wherever the scene is created and executed, so we only have one thread, that's the main thread. That's actually before SceneGraph. If you're just running a BrightScript application, that's all that exists, is this thread, right? But if you have SceneGraph, it's the same thread, then you have a scene, you have global, and you have your tasks, right? The thing is, when you instantiate the task and you start it, like, it will send to the render thread, which is the browser thread, the real render thread in the case of the simulator, which is the browser thread, that will create for each task, it will create two shared array buffers. One to synchronize to main, and another one to synchronize to task. And you may ask, oh, why don't you just do send like this shared array buffer that is here, that I'll talk a little bit. Why don't you, if it's shared, can't you make this shared array buffer just shared to the thread? So I could have like one version that is here, and then you will see immediate updates and everything directly from here to here. No, I tried that, but it doesn't work because because of the fact that we have a synchronous. Remember, this is a synchronous code running here, so I don't have events here. The events are fake. I have to stop
when you do the wait in your ports, at that moment, I need to read the shared array buffer to see if something came from the other threads. So basically, I need this pair of sync to main and sync to task. And here, the rendezvous magic happens. You receive and queue stuff here both ways, and then you shared, you send things among the threads as you wish, right? So that's how data is flowing. And for every get that I have, like in the threads, for every get in a field, then I need to send a message. That's the rendezvous. I send a message to, let's say I have a global a component that is a global field. So when I try to access it here in a thread, the object, instead of trying to read its own field, it will send a message here and then move to here and send a message here, and then the task, whatever it is, will get global, get the field you requested, send it back, and it comes here. That's the pain of, actually, I learned way more about Rendezvous developing this, because I see how really expensive it is. And I could see, testing my own apps, I could see how many dumb stuff I did, like just accessing global because it's easy, it's global, it's everywhere. No, global is not a shared memory thing. It's really, really expensive, right? So then we have this shared array buffer also used. These ones are actually shared among all the threads, and there is the render thread does not touch it. Basically, it initializes it and sends to all threads when they start, and then the data that is here is manipulated by each thread. So we have three types. First is the A, which is the main one. Is basically flags, mostly flags. There are cases where I share data, but it's mostly flags. That basically is remote control simulation, right? To send control to the main thread. Debug and logging that send debug commands, and video and audio controls, right? To say what's the status of the video playback and everything. The second type is the registry. The registry now is fully shared among threads. So whatever you change here, of course, the same way as Roku, there's no collision check. So you need to be careful when you're changing registry in multiple threads, but it works. And the file system, also we have the temporary volume, the cache FS volume, and the package volume. They are shared through shared array buffer. So you can see actually the package is just a buffer because it's read only, but these other two that are write and read can be changed on any thread and will be seen in the main thread and vice versa. So that's the threading model. It's very similar to the Roku. It's a little bit different because of the main thread that is not separated. And the mechanism is basically the same. Why I showed scene here and global? Because basically I have three different types of rendezvous, like for slightly different code for scene, global, and task, and the rest of the nodes are also involved on that. Okay, so too many images. Let's go and see some code. And not code, but execution. So I got some examples here that I would like to share it with you. First, I will just run the CLI. So the CLI, if you run it without any, can you guys see it's not too small? I hope not.
If you can zoom up one or two just for like YouTube and stuff, that would be great. I can see it on my screen though, but if you can zoom it, that's fine. If you can't, it's not a big deal either though.
Let's see if I can zoom this. I'm gonna lose time. Like,
it's fine.
Zoom your screen. You can zoom in your browser. Anyway, here it is. If you run, it becomes a REPL, so you can do anything. You can help. Then you can see print m. We have m here. I can say m something equals something else 1, right? And then I put m dot something else plus plus. It will make a mistake. What I did? Oh, no. Yeah, I just found a bug. It was supposed to work here, right? But if I do +1,
Doesn't have a BrightScript doesn't
yeah,
have a
it's 2. Yeah, it's supposed to work. I don't know why it didn't work in that case. But anyway, so it's a REPL that you can run anything. But I have test cases in our code, right? That are, see, this multi-alias app is just a small app that tests this new thing that we just discovered, that there is multi-alias. That you can put like alias fields that are like this: label 1 text, label 2 text, label 3 text, right? So when you change synced value, it will change all 3 labels, right? So I made a small application to test that. Is a test, unit test in the simulator code. So it runs as a unit test, but you can run here. I have it here. So you run BRS CLI, and then you say -r, which is the root. What is the root of your app? And then you say where is the BRS files that are on the main thread. So basically, I'm running this, and it executes, like instantiates components, do everything, and then the initial state is labels are empty. Then it adds hello world, and then it adds updated value for all 3. So basically, I executed a BrightScript application in the operational system file system. So it's not a zip file or anything. It's running from the file system. That's what BRS used to do. So the original project used to do exactly that. But you can also run applications in the zip files. So there is this example, Roku example of BrightScript with Draw2D, which is like some to demonstrate collisions in animations. So I'm gonna run using a couple of options here. Unicode, which is to render on the terminal with Unicode, and ECP, because the CLI has an ECP server that I can run and control with remote control. So basically, I'm gonna run it. It started the ECP, and now it's running. This is BrightScript running a Draw2D. So this is the collision example from Roku, and I now can use this small app that I created that connects gamepad to a Roku. So in the case this IP is my machine IP, and if I press the right button on my game control here, a new ball goes out. So this was a Roku example. It was the right button on the control. So see, I'm creating new. I'm gonna press a 4th time and a 5th time. So then I have all the balls there. See, so this is a CLI, a version of the simulator running, rendering the bitmap, the frames that are coming from the simulator as a Unicode character, so it can be shown in the terminal. And also, there is a worker, a Node.js worker running the ECP that I can send commands. So imagine this could be used by unit testing applications with visual feedback, because you can test the output of the bitmap is text, so it can even be checked by unit testing. So there's a lot of usages you could have of that, and even be controlled by automation via ECP because it's automated, right? So I can Control C here and end. So this is the version of the simulator that is the CLI version capabilities. There's another thing you can do. You can package with encryption, so you can create BPK application and everything. But let me show you the fun stuff, which is the simulator. This is the simulator. I'm fancy AI generated video and then it starts the home screen where I have some examples here. I want to show, this is the Roku SceneGraph XML tutorial. This is a tutorial from directly from the Roku dev, the Roku repository in GitHub, and it demonstrates pretty much all the functionalities of SceneGraph, basic functionalities of SceneGraph. Even the panels, like see the sliding panels, and the renderable nodes, rectangle and everything, and then up to animations, and you can have like parallel animations. So this is running the same as it runs in a Roku. And to demonstrate that I can do this, I can enable my deploy to peer Roku and sync controls. When I do that, when I run the application, it will deploy to a peer Roku that I want. See, and you can see here's the Roku, here's the simulator, and when I move here, it moves there. So if I put animations, so this way I can really see if the behavior is the same. That's basically what I've been doing to SceneGraph. So everything works. So now I will run my. This is an actual application running on Roku. Actually, if you want to use Trello in your Roku, you can use my application. So here, same thing. I have all the controls. I open it. Same thing. So see the rendering is happening, and very smooth and the same. So, and also you can debug your application by using the same as a BRS Fiddle that you most likely saw. You can have applications that you can run from here, like the snake game, and then you can run it, and it will run in the simulator. You can see what's going on here in the console. I just added this thing that to hide the editor while you're running the application, right? But this console also works when you're running here. So if you're running your application, you can see what's being debugged, right? So you can see everything, and just like in the Roku, and you can stop and debug from here. So print M here, and I see what's in M is file system global, and I print m.global. So it's a fully functional application, and it has all the. Okay, close that. So it also has all the services, right? So if I click here 80, you're gonna see that I have the application installer, and I have a screenshot. This is not a Roku, this is the simulator, but it's the same as a Roku. Same thing about ECP. You can run, and you can have like query device info. You can have all the device info and run all the ECP stuff here, right? So I have all the services here. And also, of course, you can run, let me try that, run from, I'm going to open an application here, this video list application. I'm going to run, and you can see the engine here, the library of the application is here. I'm going to run there, and because the peer device is enabled, it will install in the simulator and in the Roku. So it's installing in the simulator. See, everything is showing up here in the Visual Studio Code, and if I open here, it's also here. So I'm running the Visual Studio Code is connected to the simulator, but of course you have it running on there. So there's multiple things you could do, and you could debug from Visual Studio Code. You can put like let me put a breakpoint here, and I'm gonna restart. And it stopped. See, it stopped here automatically, but it's also stopped in the Visual Studio Code. Yeah, so that's how the state is. Like what's missing in SceneGraph. There are I could run very complex applications without a crash, but there are things. There are things that are not working. And then that's why I want the help from everyone, that if you could get the 2.1, I fixed several problems with SceneGraph in this 2.1. And so I want you guys to run your applications in this version. Actually, it's 2.2 of the desktop app, and see where it breaks, or if it's not working, like, oh, it loaded the application but it's doing nothing. There is some event that is not happening. There are very fringe scenarios that I discovered. Like, there are apps that uses the fact that you can call from the main thread functions that are inside BRS files inside the components. And there are people that uses that. I don't know why, but they call, there's a leak of scope. So any BRS file that is linked into let me demonstrate. It's easier if I show you. So see this video list thing. So this is the video list, a scene. You have a script called video list scene BRS, this BRS here. So we have an init and we have show video list, right? This sub is inside a BRS that's inside a component. There's nothing to do with a main, right? With the main thread. It's just inside there. But if I come here in the main thread after show and I decide to call show video list here after the show, and I say show video list. See, the Visual Studio Code extension will complain, oh, this cannot find this function. Okay, let's see if it cannot find. Let me run it in a Roku. Okay, I'm gonna run it only on the Roku. You're gonna see that it stops it doesn't stop here complaining that this function doesn't exist. It stops inside that function, inside the component, saying that a video list, it doesn't exist in M, because M in this context is the main M, not the component M. So please don't use that. But people use this. There are applications out there using this, calling functions from BRS files that are on the components. So even that behavior I had to reproduce in the simulator because people are using. So I had to make the leak of this. So people put basically how the people are using that, putting utility functions in BRS files that are referenced only on components, but still running that from the main. So yeah, so things like that. So please, and again, it's not hard. Let me just make my final advertisement here. It's not hard to help us develop any of these components. Let me show you how it works very quickly. See, in the extensions here, let's say there is a SceneGraph component node that is still not implemented. There are several that's still not implemented, or it's rendering bad, it's not rendering correctly, right? Like, for instance, if you go to this example here, I'm gonna call the hero grid channel. See, the hero grid channel is running, but it's awful. The zoom grid does not render perfectly. The implementation I did is incomplete. But it works kind of like you can run the application. This is but if you want to, let's say, fix this, you need to very easily find it. You're gonna see like nodes in the extension SceneGraph nodes, and you're gonna see that there is this one zoom row list, and then you're gonna see here that zoom row list is a component that extends array grid. It does not in Roku, but it was easier for me to use that. Then you go to array grid, you're gonna see that array grid exists here and extends the same way as in the Roku document. It extends group, right? Array grid extends group, that extends node, that extends a row, a component, which is so I have a differentiation. These BrightScript components, these are nodes, these are SceneGraph. So there are only two SceneGraph components, which is screen and node. So the node has all the methods that are external methods. So you don't need to touch node at all. All you need to do, if you need to implement a new one, let me show you a very simple one that I implemented recently, which is the info pane. So this info pane, see how simple it is, the implementation of it. It's very simple. It has the default fields, then initialize depending if it's FHD or HD, and then some override of the set value for some fields, the update layout because there are visible layouts, and then there is the rendering process that happens. So it's very simple to implement. You're gonna see the pattern if you open any of these, like a label. Let's see, label is very small too. See, it's 152 lines of code only, and that's basically it. It measures stuff and everything. But so please, the only thing I would like from the community is run it with your app and make sure if anything breaks, anything's missing, let me know. Are you storing color fields as number? Okay, let's open for questions. I don't have much to show you. Good question. Yes. Fields are, I try to reproduce the behavior as Roku as much as possible. So they are converted to fields. There are coercion everywhere. And there are special, I pretty much implemented, if you go to BRS.
Just for the sake of the recording, the question was, are you storing color fields as a number?
Yeah, exactly. Yes, so I am. So these are the field kinds. So in the SG types and SceneGraph types, the field kinds we have is interface, array, associate array, integer, all the integers and everything. But there is these special ones, color. There is another special one, font, which doesn't exist in BrightScript. These are special field kinds. And also these special ones like rect2d, vector2d, and vector2d array, and float array. So these are special types that are valid. And then there is this whole conversion that happens to make sure that if it comes from a string, from an XML, for instance, I have to parse whatever. Like, and it's very SceneGraph supports like string for every type, right? So you need to parse it properly. So it's all implemented. If you find problems with that, let me know. But I made a lot of tests and it's working. So all that complication is solved. Let me find our references so I can. I want to see where is the in the field here. Field has one interesting thing, like you can see here how it accepts things. So there is this function can accept a value. So if it's a number, and if the field is a number, but the value is a number, it's accept. If the field is a string, and a string or a number or a boolean, so if you're setting a boolean to a string, it works. So if you're setting, there are several scenarios, like, and the 2D rectangle 2D, what is that? It's like, oh, it could be, in some cases, it could be an array or a associative array. Both cases work. So yeah. What I'm saying is most of the complications of SceneGraph and BrightScript are solved. Now, what we need is like the missing nodes, and fix the rendering of some nodes, like, and of course find the edge cases. But I believe it's pretty much robust now. It runs lots. I'm running as every piece of SceneGraph code I found online, I'm trying to run. I found a couple of like Disney hackathon GitHub applications. So I think it's here, Disney Plus Home. So this was a hackathon in Disney. They put like in GitHub, I found, and it runs. So whatever hack they did there, it just runs. There's nothing internal. This is just like UI stuff. See, you can see this is a with the shadow in the bottom. So this is for their UI, but it's there in GitHub. So yeah, any other question?
Does your telnet connection act in exclusive mode like the Roku one does? So like when you have that up and you're messing with the debugger panel, does it also prevent you from using the VS Code extension to connect and well?
Yes, yes. Actually, not sure. I think it is, because it will. We can test it very, very easy.
It'd be interesting if it didn't have to, and we could like play in
Yeah,
both.
I don't think I prevent multiple connections, but we need to test. Yeah, we need to test. I implemented recently the external storage support, the deep linking support, so you can configure deep linking here if you want to start the application with those deep linking. The peer Roku, all the captioning, closed caption only works with SceneGraph, still not working with the old video because it was deprecated, one of the closed caption component, but I will try to implement that later. Localization works actually if you change like for Brazilian Portuguese, and you run an application that supports Brazilian Portuguese, like my game. Let's say the Quartet. Where is Quartet? Quartet is here. It supports Portuguese. So, sim, novo jogo, como jogar, créditos. So it's all in Portuguese because the device is set the localization to Brazilian Portuguese. If I put international Spanish and I restart the app, it will actually show here down that which language is currently. These two information down here. One says what is the display. This is another tricky one for SceneGraph. This resolution thing. Like if your device is in 1080, but your application is HD, the way posters and images are resized, I reproduced the same behavior of Roku, so it is working in SceneGraph too. And here is the actual resolution of the screen, and here is the display resolution, basically. So it reproduces basically the same functionality of a Roku device. What else I have here in the settings that I didn't show you? Display. Yeah, the display you can do like SD also, right? So you can change to an SD, but nobody's using SD anymore. But you can try SD. There is an overscan. Oh, that's a cool tool feature. Like you can put like guides for overscan. So this is the Roku recommended overscan. So you can see that the Roku UI. This is based on the home screen of Roku. So you can see the Roku UI does follow the rules of isolating the overscan, right? And you can even enable the overscan, so like show how it would look like if the overscan existed. So you can have that, and also frame rate. You can maximum 60 FPS because I don't see value to put more than that. And then you can limit also the FPS if your application is running slow in a machine that is not fast enough. There is options to show a performance statistic overlay here. You can enable that. The control, you can the remote control with the keyboard. You can customize some of the, like the back button, the home button, whatever you want to customize. You can do that here. Yeah, and you can also customize the channel client ID, which is returned by the device info. You can customize some these IDs. You can customize here if you want in your tests. The developer ID is the same idea of Roku developer ID, is to segregate the registry data. So if you want to test that, you put it here. Oh, and by the way, the registry data is saved on the, if you open the developer tools in the browser. So if his application is running on the browser or here in the simulator, you can come here to the application tab, And you can see here my developer ID is BRS-dev-ID. So this is the registry for some applications. So the play USB. So this is my registry. So you can actually manipulate the registry in the browser if you want to. I don't recommend because it could have unpredicted results, but you can inspect the registry in the browser. Yeah, that's a cool thing. It's very helpful to inspect what's going on in the browser. Yeah, device and the services you can enable and disable. So you can enable ACP, you can enable or disable Telnet, and you can change the port for the application installer, because like in Linux, they don't allow your Electron app to open the port 80, so you will need to put a different port. One question, does the network tab works on DevTools? It does work. It's just an Electron app, like the network here. So if I run, like say, there's a RokuCommunity, which is using the Kanban, using the Trello API. So you're gonna see everything here that is connecting. Of course, if it's not HTTPS, but you're gonna see some stuff here. The images, and just like you can throttle, you can disable cache, do everything. Yeah, that you can't do with a Roku without a proxy.
Dude, this is really cool. You have done so much work on this.
Yeah, since 2019, and I have to really thank my boss in Paramount that for the last 3 years, he put like as my personal part of my objectives in the company is to work on this project. So I could work in this project when I had free time between work there, because it's like, so it's kind of sponsored by him. And so Peter, thank you if you're out there. I don't know if you joined today, but yeah, it's very it's a project that like it helped me a lot to learn about BrightScript, and now more recently SceneGraph, because I had to reproduce behaviors, and then I really commend the developers of SceneGraph for what they did, because it's very complex to handle Rendezvous specifically, that I was working for the last 2 weeks. It's very complicated to handle edge cases and scenarios that it's there. I see Luke is here, so he probably feels my pain way more than
Do we have any other questions? Feel free to unmute yourself and ask if you want. You can type them too. Either one. So how do you handle like SSL, HTTPS, like loading certs and stuff? How does that kind of stuff work?
It's browser, right? So it will use whatever the browser is allowed to use. So
like on Roku, you have to like, sometimes you have to like set cert files for some of your networking things. Like, what do you do for that, those scenarios?
what do you mean set some?
Like, do you not have, maybe I'm showing my lack of knowledge on Roku, maybe that's not a problem. Yeah, maybe not. Security, who needs it? Yeah, I agree.
Yeah, I mean, of course, this tool is, if you want to use in production, and I plan to actually publish some of my games in, just to prove it's possible. I will publish as PWA my games, and also as Electron app in like Steam, and maybe even in macOS store, because you can put like, you can create BrightScript first application and run on other platforms with it. Having said that, I don't believe it's gonna be possible, not in the short term, to do like streaming apps, like for DRM and other security stuff. Will be hard, because this is it requires, like in an Electron app, DRM is not allowed because you need a special license, you need to link. So if a company would like to make a crazy choice to say, okay, I'm gonna publish the My Roku app in a web connected TV that it runs HTML5, because this runs, I tested the simulator in a Samsung TV, right? I could run it. The problem is, depending on the version of the Chrome that is running there, it will not work with shared array buffer. But there are possibilities, like in the future, or depending on the platform, if the platform allows you to use shared array buffer, you can run a BrightScript application in another TV platform. But I don't think that's not the objective here. I mean, my objective is really a developer tool first, like to be something that you can run. Like you, my first cool thing was, like, I was developing a game and then I was traveling to Brazil in an 8-hour flight. I didn't need a Roku. I could use my simulator and use it without having a Roku, right, in a plane, because you would not be able to use that unless you connect a router or something, Wi-Fi inside the plane, and then it will be a problem. So that's the kind of thing, right? Oh, certificates file.
That was my question. Was like,
yeah,
you can't do any of that in browser.
yeah, I do have that for simulation purposes. Is there even the certification file? But again, the browser does not support that, right? So you will need to rely on the whatever browse security we have, right? The version of the browser you have. So there are things that you can't do because you don't own actually the infrastructure, right? Another thing is like video. You can see this video list here. I tried to put. Oh, I could stop. Yeah, I could stop. Let me continue. Okay, so this has some examples of HLS, right? So, but what codecs are available is different, like in a browser, and the codecs that are on Roku. So of course, and then I try to use the same feature that Roku has to get you which codecs are available for audio and video. I get from the browser and I give to you. So that's one thing interesting that I would like to mention. Like the simulator has an option to inject features. You know, Roku has feature of is a function of device info. I don't know, it's app info, I think. There's a function called has feature that you can check if that Roku has a specific feature. So it's extensible in their simulator. So you can create a feature for yourself. First, there is one that is default, is like simulator. So you can check if your app is running on the simulator or not. For instance, Prince of Persia here, if you run it you're gonna see here, running the same code, I just uploaded the same zip files, right? Here, if you go to the game control help, see the menu says game control help, and the Roku says setup control mode. So it's the same code, but because I know that I'm running on a simulator, I change the menu, and if I press enter here, you're gonna see two different screens. See? I could do that in BrightScript. My code is publishable in like Steam and in Roku Channel Store without changing the zip file. It's the same zip file, but because the has feature, you can customize that. You can send all features you want. Let's say if you go to here, one thing that I implemented. This is the website that has the BrightScript TV, which is you can run without anything. But I introduced this touch mode that you can run in your tablet or your phone, right? The touch mode. See, there's touch controls. When it has touch controls, what happens is if you run Prince of Persia, you could have a third screen explaining see, touch control help. It does not say remote control. It is a third option because I said, no, this is a touch control, so it has a different help. So you can make your application really multi-platform because you can inject, and it's all documented in the repository. There is a documentation, and you're gonna go there. There's one which is how to customize. There's several ways you can customize the simulator behavior. Okay, is here is called customization. Yes, so you can customize. With like, also you can detect the platform. That's another thing that is on the has feature. You can say platform is browser, it's Chromium, it's Firefox, it's Safari. So you can make it really, and then I didn't need to create a new API for Roku. It's the same API exists, has feature, and then you can gather information from it. right? So specific. Also, there is a special manifest and 2 special manifest entries that I created. One is multi-key events for Prince of Persia. Of course, the Roku remote control is limited, right? But when you are running Prince of Persia, you know that you can use in a PC, you can use the shift to walk, and without shift you run. In a remote control, that's very hard to do. So you had to have a toggle to stop, use a key to toggle, walk and run. But with this special manifest multi-key events, I unlock BrightScript to support multiple key events at the same time. So you can handle, just like any gaming platform, multiple like shift and press and up and everything. Of course, that changes the behavior of your app, and you need to account for that, but that's possible with the simulator. This is mostly for games, but it's interesting. And also the CORS proxy, I have a feature. Oh, that's one limitation about security is, like when you're running on web, right? You have a CORS problem. So in BRS Fiddle, let's say you want to run the video list here, right? So the video list runs several videos from different places. Some of them are not CORS. CORS is a big problem of like cross origin, right? It's cross origin security. There is a tool, there is a proxy that I installed in a service that you can use, but you can use in your local machine or anything like this, called CORS Anywhere. So once you have that proxy, you can point the simulator to the proxy, and then it will use that proxy, and then you can access images and files from cross origin when you're running on that. Electron apps don't have that problem, but in a browser you do. So I had to do that for BRS Fiddle because people would try to test their own APIs or some file that is somewhere with an XML, and it will not work without that. So these are the customization basically that you will be able to use. And of course, control mapping. You can map the control for different keyboard as you wish. What ECP queries are not yet implemented? Oh, good questions. I have actually in my Trello here. There is very few, just recent ones.
You should show me Trello in the Roku app while you're looking.
What?
Why should you use Trello in the Roku app to see what isn't implemented yet?
Yeah. Now the ECP, the ones that is a more recent ones that get information about the media that is playing, those new stuff, that is not implemented. But most of all the things is registry works, all the registry related ones, all the commands and everything. Most of those are implemented.
What about app UI?
Yeah, that's the one. Yeah.
No, not yet. No, that one, because that's really anything related to SceneGraph was I actually did not touch until I finished. Like Rendezvous stuff, also the Rendezvous service I will implement eventually because it's useful, but I didn't have Rendezvous, so I couldn't do that. Same as all the SceneGraph related ones, ECP commands are not there yet. It's mostly regular BrightScript ECP and commands and everything.
Mark,
all the ECP is more complete in a desktop project than in the CLI. Just to know if you want to get the latest.
Brian, do you have a question?
Yeah, I was going to say, Marcelo, just obviously I get the limitation with the certificate stuff with being the web pager like that. One simple option would be, because obviously I think part of this is to be able to catch issues in your application or like that, would be basically, if you have a ROURL transfer and you have not set the set certificate file, that you would, if it's an HTTPS request, you would just fail it the way that the Roku would fail it.
Yeah, there are ways. And then again, running on an Electron app, you have some kind of like security things that are easier to handle, and vice versa. So it depends on the kind of use case, but yeah, there will be limitations.
Do you have support for sockets yet?
That's a big problem.
Okay.
With browser don't support sockets, right?
Right.
So maybe the Node.js version will be able to do it. I think it's useful. I'm planning to implement. Currently, the socket component is there, but it will give you a warning saying sockets are not supported. Sorry, because the browser does not, for security reasons. Again, browser do not support it. So we would need to create some kind of proxy or something to emulate that. Maybe in the Electron app it would be possible if I create a special service to interact with the simulator, but it's complicated. So yeah, and I realize a lot of production app uses sockets for different things. So yes, it's a problem too. That this is another limitation.
Are WebSockets, forgive my ignorance here, but are WebSockets different than like the Node.js sockets? Like, isn't it still passing binary back and forth in a way that we could make it work with WebSockets?
Yeah, WebSockets are possible, but
because you wrap that in the road socket thing anyway, the road datagram, wherever that is anyway, wouldn't you?
Yeah, it could be something like we could use WebSockets, and also the Roku has the WebSocket component that is not documented. It is not. Nobody knows how to use it, but it's there. I did not. I created also a mock just to exist.
Maybe the problem is actually the server side, because the other side would need to also be WebSocket. So maybe that's the disconnect there that I'm missing.
Yeah. We need a proxy somehow, some kind of proxy to translate back and forth and everything. So yes.
But Brian, for things that use sockets like RTA and such, we could probably have like a little make it work on the simulator with WebSockets adapter or something.
Yeah, for sure. Yeah, there's definitely.
Yeah. It would be write something different, right? Because then actually in the simulator we have way more flexibility than a Roku device, so you could be creative and implement some custom way to do that if it's for interaction with VS Code or anything else.
How is the performance versus an actual device?
Depending on what machine you're running, in my Mac Mini, it's way faster than Roku. In all kinds of actually, I need another shout out like here for Mark, because Mark did a breakthrough like a couple of years ago when I was struggling with even before SceneGraph. Mark, that is doing like 1.0 with you guys. He used to work with me in Paramount, and he was developing his game platform for BrightScript, and the performance of the 3D stuff was very bad. So you probably remember he created this. I don't know if you guys saw that, but it's so cool. He created this game engine that is 3D. So see, this runs on a Roku, right? With this 3D, this is all draw 2D. This runs on a Roku, and Mark created that, and it would run on a Roku like smooth like this, but not in the simulator. Simulator would be jaggy, 1 frame per second and everything. And he took a look at my code on the draw 2D canvas drawing, and he tweaked it, and it made a miracle. Like it just made it perform perfectly. So all the things that are happening actually now in SceneGraph is because Mark did that big commit on the simulator. So he's really did a big contribution to us.
I haven't worked on that spinning cube thing in like 2 years. I'm like
still here.
Once or twice a month, I think, oh man, I really should.
Yeah, this is another cool thing he did. See, this also runs in a Roku. Actually, this is failing in the recent firmwares. I don't know why, Mark. If you try this on a recent Roku, it's not running anymore. It's still running in the simulator. But
blame it on OS 15.
We can blame a lot of things on OS 15.
Yeah.
If 15.1 or 15.2 will do better.
Yeah, but yes, that example I showed on the CLI is this one. Of course, looks better. Yeah.
Like we Marcelo and I also worked on a video, basically a video benchmarking tool for Roku, and absolutely the fastest Roku in terms of like video or graphics processing was like a Mac M3. So like
Yes. If you're talking about rendering, yes, of course there are other things that Roku will run natively and faster. But even the tests about like arrays and everything, if you're running a fast machine, it beats Roku. Yeah.
Yeah, I'm just thinking, obviously, like with the Roku automated tester like that, like if it is fast enough, obviously one of the issues with both unit testing and automated test is like requiring a Roku device. If you were able to like run in the cloud or like that, that's a huge win. So
yeah. No, yeah, I think we can explore more, even the Node.js side of things. One of the things I could not move much in the Node.js side of things is the following. I use the Node Canvas package, which is an amazing package. They got the Canvas and implemented for Node, and it generates the same API as the browser. You can run in a server. It's amazing, but it does not run in a worker. There is an open ticket because of an isolation thing and everything. So there's an open ticket in the repository for years, and nobody's touching that. And every year I go there and say, how can you please fix this? Because once they do that, I can run we could run even SceneGraph I can't run on the CLI yet. I can't run tasks, right? I can run one thread, but not multiple threads yet, because I'm waiting this canvas. I probably will create a mocked canvas. If you don't need visuals and you just need the tasks, I will probably have to create a Node.js core library without canvas, like with a mocked canvas. So we could use like all the SceneGraphs. I mean, really run a SceneGraph application in a server, like in a Docker container, and it would run everything except generate visual frames, right? And then if you're not testing actually visual behavior, it's not important. So I probably will work on that Canvas mock. So for a version of the library that doesn't generate, because all I need the Canvas is because the backend generates images, but SceneGraph it doesn't rely on that like for anything. So if the draw to the component that draws is not available, the SceneGraph, all the rendering happens and the calculations and everything happens regardless of that. But because of the reference to Canvas, it's a problem to build the Webpack.
would like a headless Chromium be an option?
No, yeah, but the thing is, Node.js has advantages on the networking side. That's not a limitation. Even the socket thing, like we could create a headless using the Node.js. If it runs on the open threads and everything, I could create a full Roku thing without screen. And even if they fix the problem of Canvas running on the node, then on the worker, then we could even have in the terminal, like remotely, and see in the terminal. So yeah, get the binary, because actually I get the binary frame, and the transformation to the ASCII or Unicode on the terminal is done very quickly. It gets the bitmap and does that. So you have the bitmap. You can even, like in a unit test scenario, save screenshots, right? So you receive the screenshots actually from the interpreter. So you can save screenshots, look, and make your unit testing or your test automation to save that in some repository. So whoever is reviewing the failed scenario can see the screenshots or create a video from those screenshots and something like that. So it's all automatable the way it is now.
You said the capture screenshot ECP request does work, or what? Or not the C.
It does. Like it does.
How fast is our take screenshot?
I'm pretty sure it's faster than Roku.
What?
I'm pretty
So
sure
our
it's faster
device
than
view
Roku.
and VS Code extension takes a screenshot as fast as we possibly can. So the moment we get one, we ask for another one, then we ask for another one, we ask for another one.
Okay, got it.
I would love to know what happens when we do
Last
that.
time I tested. Okay, let me test it here. So
Any Roku employees out there, we'd love to have ways to get screenshots faster.
Yeah, it used to be a lot faster.
okay, let me run.
'Cause I think most of the time it's like 1.5 or 2 seconds per screenshot. And if I could be like, just give me like, I don't know, 300 by 300. If it would come back faster, that would be awesome.
Okay, I'm disabling the peer Roku thing, and I'm gonna run RokuCommunity and it's running. Oh, but I need for the screenshot. I think for the screenshot,
You should just need to open up the device panel, or the device, the device view panel. So typically it's under the
it's here.
debugger.
Yeah,
No,
it's here.
that's to take one. No, go to the debugger panel.
Could not capture section canceled. Oh, I think it closed. Nah, I know what is it. It's because is you have added that. Okay, I need to disable enable. Okay, false. Okay. Okay, let me run that. So what do you want me to show?
So go to the debug panel,
Okay.
and then there's one down there called is it there? Device view? Or can you right click on your panels and see
It's
if
here.
there's
No,
one?
it's here. It's here.
Oh, there it is. Yeah.
Let me do this. I will move here and then let's see.
Yeah. It's about as fast as a Roku.
Yeah, but I will need you to see what. Yeah, it's. Yeah.
I'm surprised we're not locking you up more than we are there, because I mean,
Yeah, you're not locking me at all. See, I can do
Yeah.
that. I can do whatever I want. Is your. I was slow just to see the lag, but no, I have a.
and then if you close the device view so it's no longer focused, it won't do the screenshots anymore. Does the app feel any snappier when you close the device view?
I don't
Yeah,
think
like that's it. That's good enough
not
there.
here. If I tested a slow machine, maybe, but it's not, because the thing is, it's using the same, because I'm sending all this screenshots. In reality, I'm sending screenshots to the browser renderer.
Right.
And all I do
Yeah.
is to serve the last image I got. That's all I
Right.
do. I don't need to request a screenshot. It's there already, right? So I get the last version I have. So it's it doesn't affect the performance at all. I can do whatever I want here. It doesn't affect it would affect your end if you don't get fast enough. But yeah.
That's great.
Yeah. Okay, I have to go to lunch, man. Sorry, I hold you guys way more than needed.
That was great. Thanks, Marcelo.
It's all good, man. This is fantastic.
It's amazing, and
And
I
I
can't
wish-
wait to like integrate it more into my workflow, our team's workflow. I think that it would be amazing.
Yeah, we are getting close, guys. I was skeptic in several moments in the timeline of this project. I was skeptic that I would hit a roadblock, and I would say, no, I can't pass this. This is gonna be good. But then I always find Mark or find another solution that moves us over. So I think at this point, I'm very confident that we can have a very useful tool. All I need, I'm gonna focus now to try to implement as much missing nodes that are there, and also fix some ugly behavior of some of these grids. But other than that, I think we're very close to have a very, very useful tool. Thank you, everyone. See you next time.
All right. Well, I think yeah, we'll call that time for now. We're at an hour and 24 minutes. So thanks everyone. Have a great rest of your day.